Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, another video in our series of dealing with mathematical induction, we're going to do another example of a proof by induction. It's another series that we want to prove, and the series, once again, I've sort of been concentrating on the O.D. Morris text, which is the higher leaving cert maths textbook, and I've sort of been pulling sort of examples, let's say, from there. But look, I mean, these particular series are well known and can be accessed anywhere. So let me just give you the series, and so we want to, let's say, prove that let's say 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus all the way through to the nth term, 1 over n times n plus 1. We'd like to prove that the sum of that series, is equal to n over n plus 1 for all n that are elements of the natural numbers. Okay, so we'd like to prove that. And don't forget that proofs by induction have 3 steps. The first step is we need to prove that the statement is true, when n is equal to, we want to do it for all the natural numbers, so we need to start with 1. So when n is equal to 1, we'd like to prove this true. And let's just take the left hand side here of this particular statement, the left hand side. Okay. From the left hand side, what we actually get is that when n is equal to 1, we end up with 1 over 1 times 1 plus 1, which is equal to 1 over 1 times 2, which is a half, which is exactly what the first term is in that particular sequence. That's the left hand side. The right hand side is, well, it's n over n plus 1. So when n is equal to 1, it's 1 over 1 plus 1, which is equal to 1 over 2. I think clearly we can see here, clearly that the left hand side is equal to the right hand side when n is equal to 1. Okay, so we know that this is true when n is equal to 1. So we know it's true when n is equal to 1. Okay, the next part of this inductive process, is to assume that this is true for all numbers up to a specific value, and the specific value, the general value that we're going to choose is k. So let's say part 2, we're going to assume that 1 over 1 times 2 plus 1 over 2 times 3 plus all the way through to the nth term plus 1 over k times k plus 1, is equal to k over k plus 1. We'll assume that this is true. So assume that it's true that the statement is true, for n is equal to k, some specific value. So we're going to assume that this is actually the case. So this is an assumption now. It doesn't make it true. We're just assuming it to be true, that actually 1 over 1 plus 2 plus 1 over 2 plus 2 times 3 plus all the way through to the kth term is actually equal to k over k plus 1. Okay? And then what we'd like to do is, part 3 is we'd like to prove true for the next term in the series. So prove true for the n is equal to k plus 1, the k plus 1th term. Okay. Now, if you look at this particular term here, if you look at the let's say examine this particular term here, 1 over k times k plus 1, or if you look at, I should really say, look at this particular nth term here, so the nth term, the k plus 1th term would be the term after this, which would be 1 over k plus 1 times k plus 1 plus 1, which gives us k plus 2. That'd be the k plus 1th term in this particular series. So we'd like to prove true for n is equal to k plus 1. So what do we need to prove? Well, we need to prove that we must show, so we must show, and I'll just underline this here. What do we have to show? We have to show that 1 over 1 times 2 plus 1 over 2 times 3 plus all the way through to 1 over let's say 1 over k times k plus 1, plus the next term after it, which is 1 over k plus 1 times k plus 2,